Alright, let's do another quick kit build. Another one of these little tiny things that I got off of Banggood. This one is just going to be a simple astable multivibrator based on 2 transistors and some capacitors. I'll do a video on how a transistor-based multivibrator works, but basically it works on the charging and discharge cycles of 2 LEDs, which provide current flow to the bases of these transistors, and it basically just alternates LEDs on and off by creating feedback across the transistors so that one is off while the other is on, and then of course one capacitor is charging while the other one is discharging. It's a neat little concept. It's not particularly accurate by any means, but you know, for a little back and forth flasher like this one, it does the trick. So we'll do our normal thing where we start with our resistors here, and we'll start with these ones, which are 10K, black or brown, black, orange, 1 0 and then 3 zeros. So let's go ahead and put those into place. The 10K resistors go here in the middle of the board. This is just a single-sided board, so I may reverse engineer it later, but I'm probably just going to do a video on transistor multivibrators and write up my own diagrams, and probably even build one on my protoboards. So let's go ahead and solder these into place. These are going to be a little messy, so I'm just going to do 1 pin of each of the resistors and then get them centered, and then solder the other pin. There we go, there's that one, there's that one. I know I repeat myself a lot, but I do that because in this particular niche, people might not necessarily subscribe to my channel. They may just search for a video, you know, demonstrating this particular kit build if they bought one themselves and they want some guidance. So they potentially won't have seen my other videos where I explain my techniques. So I like to reiterate what I'm doing on every video, just to reinforce it for anybody that hasn't seen other videos. Alright, so the next one we'll do is the other resistors here. And these are 470 ohm resistors, so they're going to be yellow, violet, black, brown, yellow, violet, brown, 4 7 and then 1 0, so 470. Alright, and just because I'm kind of weird, I like to make sure the resistors are all, the color bands are all pointing in the same direction. Makes absolutely no difference to the circuit which way you put a resistor in. It's basically just a piece of carbon or metal. So the direction of the current going through it doesn't matter. But for visual purposes, I like to have it kind of neat. Alright, so solder 1 lead there, make sure they're nice and flush. Again, they don't have to be neat, but I like to make sure it looks nice too. Alright, we'll go ahead and trim those leads, add them to the growing pile of leads, because I'm doing a couple of kit builds today, one after another. There we go. And the next thing we'll put on will be, we'll do the caps, I think. Wait, where do the LEDs go? Oh, they go there. Oh, that's weird. Wow, I'm glad I was paying attention. I almost put the capacitors where the diodes go. Alright, so the diodes go, or the capacitors go here in the middle, some 47 microfarad, 16 volt, bog standard electrolytics. We've got some markings on the board here for positive and negative. The shaded inside is the negative, so that'll be the bar on the side of the capacitor. and they're pointed in at each other. So the negative of one points at the negative of the other. So I'll just go ahead and get those in there. And as usual, just solder one lead. Make sure they're nice and flush. There we go, there's that one. And this one looks pretty okay, but I'll double check just to make sure. Yep, we're all good on those. Then we'll tack on the remaining leads. Like so. Bonk bonk. There we go. Alright. So there's that done. Brilliant. Now we'll do the we'll do the LEDs. I haven't tested these LEDs, so let's go ahead and test the LED. I do that with a little lithium coin cell. Long LED or long lead of the LED goes on the long section of the battery, as Julian Eilert would say, and got a nice bright red water clear there, and a nice bright red water clear there. So again, following the diagram here, we've got a plus and a minus where the diode goes, as well as a little flat mark on the side. There is a flat side of the LED. And also, typically, although I have run into a couple of LEDs where this isn't the case, so it's always good to check, but typically the longer lead is the positive lead. So, you know, the plus side lead is the plus size, or plus side of the circuit. But you can also look on the inside. The negative lead is always the bigger section inside the LED, so you'll have like a little reflector cup with a triangular section leading down to the lead. That's always the negative part of the LED. So whenever in doubt, you can always look for that little sort of anvil-shaped section inside the LED and position the LED based on that. So these LEDs are super loose, so I'll need to be careful while soldering them so that they don't get too off kilter. And of course we'll do our usual component centering trick once we've got one lead in place. There we go. Get this one nice and centered. I put way too much solder on that joint. Looks like I actually did pretty well despite how loose they were. Let's see. Oh, that looks a little like a cold solder joint. That's weird. Just going off camera here to have a closer look at the leads here. Yeah, they're not taking solder. That's interesting. My flux pen is getting a little dry. I'm gonna have to revivify it with a little bit of isopropyl alcohol. Okay, what do we have here? Yeah, that looks a little better. That's probably just some oxidation on the lead. Interestingly enough, these leads tend to be made out of steel. I can prove that by picking up a bunch of them with the magnetic screwdriver. Now we just need to add the transistors. Now the transistors are S9014s. I believe that's an NPN. But let's go ahead and find out for sure. So we'll just plug this into the good old component tester, of which I actually need to buy a new one because something's wrong with the display on this one. But, ooh. Yeah, so it's an NPN. Pretty bog standard, normal everyday transistor there. So we'll go ahead and you'll see that there's sort of a D shape, well, backwards D shape on the board there, and that lines up with the shape of the transistor. So we'll just line up those leads and push it down to the board. There we go. Push this one down right onto the board like so. And we'll go ahead and just solder them straight on. Transistors are a heat-sensitive component, so I'll just switch back and forth on the legs here to try to prevent any excessive amounts of heat from building up in the transistors. I'm sure this, just a little solder iron like this wouldn't cause any damage, but it's a good habit to get into, making sure that you treat your heat-sensitive components with a little bit of care. And where did my snippers go? I put them away. How unusual. Alright, so just going to nip these off. Okay, this is probably going to be the first time in a really long time that I've done a single take video. No jump cuts or batteries running out or pauses to look up information or find a tool or anything. Alright, so last is the power connector. We're just going to kind of carefully... There's a lot of metal here, so it's going to take a bit to get the solder to flow. Yep, I'm doing that totally off shot and out of focus. I'm hoping in the future to scrape together enough money to get the get a higher quality lens for the camera, because the autofocus on the default lens that came with the camera is very, very noisy. The servo inside it is quite loud. Anyway, I'm going to carefully nip off the ends of these, using the back of the jaws so that I get lots of torque on the cutter. All right, so that's that one complete. Let's just turn off the soldering iron and move it off to the side here. And what is the input on this thing? 3 to 9 volts. Wow, that's rather generic. Let's see, is this small enough to go down in there? No, it's not, so I need to find a smaller screwdriver here. And I'm also going to need a couple of jumper wires. So I'll just grab a couple of these pieces of scrap wire that I have in the drawer here. Let's give this circuit a little test. Now this shouldn't do anything super exciting or flash. Well, I guess it is flashy because the lights are flashing, but now this shouldn't do anything super complicated. It's just going to blink back and forth between the two LEDs. So I'm just going to stick a couple of jumpers into here. Oh, that's not working. Why is that not working? Maybe I didn't open this up far enough. We'll back it way up. That's more like it. Okay. And then the other one, I'm going to plug it into here. Yeah, that's it's a very tight terminals. There we go. Alright, and then plus is the one on the right here, or the left. That's the left side, Chris. Now it's the right side. So that's positive, blink, and then the negative, blink. You can see it just flashes back and forth. Nothing overly exciting. If you pay really close attention, you might see a slight limp that's due to difference in these capacitors, so they won't blink perfectly. Ooh. Oh, that would probably be because it's not drawing enough current. But yeah, it won't be perfectly illuminated on and off, 50%. Actually, it would be interesting to connect an oscilloscope to the... I wonder if I could do that. I may figure out a way to do that so we can actually see what the duty cycle on that flip-flop is. Anyway, so that's just that cute little kit build there. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting based on your watching habits. Right here is the kit builds playlist, and right here is a link to Patreon, which you can use to help me buy more stuff like this. Thanks so much for watching, and we'll see you next time. Bye-bye.